All right, so I asked you to look at the section on parallel and perpendicular lines, and the theory is quite easy. Essentially, if you have two lines, and we've learned how to find out the gradient between two lines using the gradient equation. If you have two lines that are parallel, the gradients are going to be the same. So, for example, if I have a gradient of, say, m is equal to 3 for one line, and I ask you, give me another line with the same gradient, you're going to say the gradient is 3. And it makes sense because if they're both going up at the same amount, right, they should never touch. They're parallel. So parallel lines never touch. The rise over the run is the same for both lines. Now for perpendicular, it's quite simple as well. And I tend to use this thing called the flip and switch when I'm using perpendicular lines. So every time I see something with perpendicular lines in gradients, I use this flip and switch. And it's very easy. Essentially what you're doing is you're taking the reciprocal of the gradient and switching the sign. So the flip and switch, as I call it, what you do is you flip the denominator and the numerator and you switch the sign. So if I have a gradient of -3 here, then the flip would be, well, if this is over 1, now it's 1 over 3. So that's the flip. And the switch is, if this is negative, now it's positive. So we have a gradient of -3 over 1 and a gradient of 1/3. So those should be parallel. So something we've learned is that if you have a negative gradient, it is a line leaning back like so. And then if you have a positive gradient, it's leaning forward. So a gradient of -3 could look like this black line, and then a gradient of 1/3 could look like this orange line, and then these cross at a 90-degree angle here. So that's what we have for perpendicular lines. And to prove you have perpendicular lines, it's quite simple. If I give you two gradients, right, m1 and m2, let's call gradient 1 m1 and gradient m2, gradient 2 m2. If you multiply those and you get -1, for sure they're perpendicular. So if I use my example here, and I have -3, which is, I'll say this is m1 here, and m2. If I have -3 times 1/3, you will soon see that that gives us -1 in this case. Okay, so that's a proof. So if I ask, are these perpendicular? Why? You just need to take m1 times m2, check to see if it's -1. If it is -1, they for sure are perpendicular. So there's a little bit in theory on perpendicular lines. I have some other ones here, some questions where I just ask you to make sure you know how to do the flip and switch. So for example, if I go back here, a gradient perpendicular to this would be -7 over 2. In this example would be +11 over 10. In this example, you would have to change this to a fraction. So if that's the case, -1.2, you have to do a little bit of work. 0.2 is like saying 2 over 10 or 1 over 5. So this is -1 and 1/5. If you change this to an improper fraction, you should get -6 over 5. And now we can do the flip and switch. So a perpendicular gradient to -6 over 5 is +5 over 6. Okay, so you need to do a little bit of work there. And my final one, this is quite easy again, flip and switch. So flip, and I switch this negative to a positive. So that's all you need to know about the theory of parallel and perpendicular lines if you had any trouble. So once again, we have some questions like consider the points 1, 0, 2, 4, 5, 1. Show that the triangle ABC is isosceles. We did that with the distance formula, if you can remember. So if you can find the distance between two sides, and two of the sides have the same distance, we know it's an isosceles triangle. The midpoint is quite easy between B and C. You use a midpoint formula that we worked on earlier on last week. And then finally, if we have used gradients to show that AM and BC are perpendicular, so if this is the case, we have to find the point M. And I can do that here, this part of the question for you so that you can see. So if we put that up here, all right. In order to do that, we first have to find the gradient of BC. So if I find the gradient of BC, remember we have y2 minus y1 over x2 minus x1. All right, so y2, let's see. So BC, I'll make this x1, y1, x2, y2. So y2 minus y1, 1 minus 4. And then x2, 5 minus 2. And that gives us negative 3 over 3. So we have a gradient of negative 1. All right, so that's the gradient of line BC. Okay. Now if we want to find the midpoint of BC, we have the x midpoint, which is x1 plus x2 divided by 2. So 2 plus 5 divided by 2, which is 7 over 2. Midpoint of BC, 2 plus 5, good. And then the y midpoint is the sum of the y's divided by 2, 4 plus 1 divided by 2, and that gives us 5 over 2. And then in this case, we have our point. So we have a gradient of negative 1 between BC and our midpoint, which is 7 over 2, 5 over 2. So that's the midpoint of BC. So if I draw some ideas here, we have, in this case, move this over a bit. Uh, 1, 0 should be here, you're at point A. Your point B is 2, 4, so 1, 2, 3, 4, that's point B there. And point C is 5, 1, so 1, 2, 3, 1, 2, 3, 4, 5, and 1. So you need to plot these points. If I join them with a line, we have one line there. Let's see if I can make it a little bit straighter. The points. We have one line there. And then we found the midpoint of BC. And that's approximately 7 over 2 and 5 over 2, which is about here. So 3.5 and 2.5, which makes about right. Here's about 2.5. Here's about 3.5. So this looks good. And now they want us to see if the gradients of AM and BC are perpendicular. So if I draw a line connecting A, and now I can label this point M here. That's my midpoint. If I connect these two, that kind of looks perpendicular, right? So let's find the gradient of AM, and if we take the gradients in the end and multiply them and we get negative 1, we know they're perpendicular. So I already have the gradient of BC, that's here, negative 1. So the flip and switch of negative 1 is positive 1, so I'm hoping that for the values of AM, I get positive 1. So let's take a look. If I go, so the gradient of AM, oops, I don't want to put that too close. So AM, that's this gradient. So let's make my A x1, y1, and let's make my M x2, y2. That way I can concentrate on which one is which. So y2, my point of y2 is 5 over 2 minus y1, and my point at A, as you can see, is 0, divided by x2, which is 7 over 2. Remember, this is my x2 in this case, minus x1, which is the x1 at point A, which is 1. So minus 1. And if we do that, we end up getting 5 over 2 on the top. And if 7 over 2 is 3.5, remember as a decimal, 7 over 2 is 3.5. If we subtract 1, we get 2.5, which is the same as 5 over 2. And ta-da, our gradient is 1. So now we can prove that negative 1 times 1 gives us gradient, gives us our proof that m1 times m2 is equal to -1. So -1 times by 1, perpendicular gradients gives us -1. So ta-da, we proved that here AM and BC are perpendicular with each other, okay? And as you can see, it says illustrate ABC on a set of axes, which is always good. So you should always do this and try to make sure you draw some pictures. So draw pictures of these whenever you can, if you can plot them on a point, okay? So that's some ideas on parallel and perpendicular lines, okay? Let me know if you have any questions and you can work through the problems in the book.